think it's the 25th. And we will continue with 2.5, transformations. So first of all, what do they mean? Transformations are helping us be able to, number one, fit a function through a data set, and number two, deeply understand a function. Not all functions, but 7 functions that I am going to list next. So before we talk about transformations, we have to review 7 functions and their graphs. So I call these functions basic or base functions. And can anyone give us the simplest possible linear function? The simplest one that you can ever think of. Say it again.
Equals x squared.
That is not linear. Careful. That will be our next. Quadratic. F of x, x squared is the simplest possible quadratic. But I need the linear first.
N of x.
Say it again.
N of x. So put an n value in front of x.
Well, the simplest would be with 1, right? So that's the simplest linear function is f of x equals x. So let's graph this. We have to remember it with a graph. So here's the graph. It bisects the first and the third quadrants. So this is y equals x. Can anyone tell us whether this is Can anyone tell us whether this is odd or even or not symmetric? It is odd. Awesome. Very good. So we already talked about the simplest possible quadratic. Here's the graph of the simplest possible quadratic function. We knew this from before, from symmetry. We discussed this several times. Can anyone tell us whether this is odd, even, or not symmetric? It is even indeed. Very good. Can anyone give us the simplest possible cubic function? Very good. Of course. Makes sense. Very good. We know this graph. Again, we used it at symmetry before. Here it is. Please pay attention how I graph this function. This is not crossing the x-axis like this. And you will see how and why in chapter 3. We're going to discuss this. Okay? This is a different type of cross, and this is a different type of cross. They're totally different. Can anyone give us whether odd, even, or none of the above? Of course. Of course, it's odd. It's symmetric with respect to the origin. Great job. Any questions so far? You know that you have to ask questions and anytime you have a question, right? I don't have to say it all the time. Okay, next function. The simplest possible square root. Can anyone give us the simplest possible square root function? Awesome. Can anyone give us the domain of this function? 0 to infinity. Excellent. Well done. Well done. So it is 0 to infinity. So let's graph it now. Here's the graph of the square root of x. It's not a straight line. Be careful. Odd, even, or not symmetric? Excellent. Of course. Not symmetric. Not symmetric indeed. Absolute value function. The basic function, the simplest possible absolute value. Very good. If you remember, this is like a V bisecting the first and second quadrants. Y equals the absolute value of x. Odd, even, or none of the above?
You did.
Absolutely. Perfect. Cube root function. Two more. This one and one more. Cube root. Can anyone give us the simplest possible cube root? Excellent. Cube root of x indeed. We have to remember all these graphs. So this is y equals the cube root of x. And odd, even, or none of the above. Very good. Awesome. Last one. Can anyone give us the simplest possible rational function? F of x equals? Say it again.
C over?
I couldn't hear you.
I said C.
Rational. Thank you. Indeed, this is the simplest possible rational function, 1 over x. And here's the graph. You may have seen it in the past or not. We're going to talk about it extensively, in details, in great detail in chapter 3. So here's the graph. I just want you to see it and get used to it. I'm not going to do a lot with this one at this point. Okay, but it's a very important function. So odd, even, or none of the above. Of course. Perfect. Great job. Now, keeping in mind these 7 graphs, we are ready to talk about transformations. If we don't know these graphs, transformations have no meaning. So let's start. Transformations. Once you understand the transformations, you will be able to picture a graph in the next maybe half an hour or less. You will be able to picture a graph without punching it in the graphing calculator, without even touching a pencil or pen. You're going to be able to picture the graph, and you'll tell me what it is and how it looks like. But we have to understand transformations. And there are 3 major groups. Three major groups. The first one, shifts. The middle one, reflections. And the last one is a combo, stretching, shrinking. Okay, vertical, horizontal. WRT with respect to the x-axis, the y-axis. Vertical, horizontal. So we're going to look at 6 different situations. 3 groups, but a total of 6 different situations. Ready? Okay. So I'll go to the next page. I don't have enough room here, or maybe I do. Okay, so let's look at first one. I'm not going to tell you what it is just yet. We are going to discover it together. Okay, I just created a function, and the function is the absolute value of x minus 2. And now I want to create one more function, which is the absolute value of x plus 4. First of all, I'm going to ask you, from those base function or basic function, whatever you want to call it, from that list of 7, which one did I choose to create f and g? I only picked one particular one out of 7. Of course, of course. Makes sense. My next question to myself is this. So as you've noticed here, there are also 2 major groups. One group of transformations, that is a change in x. Every time I change x, I have to be on the horizontal axis, something happens left and right, whatever. Whenever we change y, of course something happens vertically, right? So after I establish or find the base function that was used for these two, or for any function, then I ask myself, okay, I will compare this to this and identify whether the change is in x or the change is in y. What do you think? Since this piece, which is x, and the absolute value, is identical in both functions, the base and f of x, the change cannot be in x. There's nothing that I changed in x. X is the same, the absolute value is the same, so the change happens outside. It does not touch x. It happens outside x, away from x, so it must be a transformation in y. So if we graph the base function, we know now how quickly we can, and we will be graphing a lot in this section. So I graph the base function, and then I ask myself, what transformation is the absolute value of x minus 2? And the answer is a transformation in y. But what does it happen? What happens here? What is the change? So this is the graph of the absolute value of x. How do I graph this function? Down 2. Awesome. So this is a vertical shift to down 2. Vertical shift down 2. So I'm graphing now 1, 2. Make sure that the sides are parallel to the original function. And this is the absolute value of x minus 2. Awesome. So when I change y with minus a number, the graph goes down by that number. Okay, now can anyone tell us how to graph function g? You all agree with up 4?
Yes.
1, 2, 3, 4. Here it is. So this is the absolute value of x plus 4. So this will be a vertical shift up 4. So basically that's all I had to say about the first one. Okay, let's move on. I'm going to create now two functions, f of x, which is x plus 2 squared, and g of x, which is x minus 3 squared. Yes, I'm going to ask you the same question again. Which base function was used here? Yes, quadratic, which is x squared. Very good. So base or basic function, whatever you want to call it, the initial function used is x squared. Now my next question is, what am I changing? Because if I'm changing y, the transformation is going to be something on the vertical. If I'm changing x, something will happen horizontally. Not both. So do not expect that there is a transformation that changes both x and y at the same time. No. Okay, so then I compare x squared. I thought I could put my tent away, but apparently not. Is that better? So I'm comparing x, of course it's squared, but it's x, to x plus 2. And I have to decide whether I'm changing x or y. I am changing x, right? It's inside, and the change, or the plus 2, touches x. It's not completely outside of the function. It touches x. So here I'm changing x into x plus 2, and here I'm changing x into x minus 3. Do not answer just yet. I'm going to graph x squared first, and here it is. And I am going to ask you, where is the vertex of this function? We have some experience with quadratic functions. The vertex is this point or of either max or min. In this case, it's min. That's the vertex. Where is it? Of course, at the origin. Now, the question I'm asking next is, where do you think will this touch the x-axis? So this one touches the x-axis at 0. Where will this touch the x-axis? Let's check. 2 plus 2 is 4. 4 squared is not 0. So it cannot be at 2. So one more time. Where will x plus 2 touch the x-axis? At? Correct. So this is a horizontal shift of 2 units to your left. Where will the second one, g, touch the x-axis? Yes, because 3 minus 3 is 0, and 0 squared will be 0. So the other one shifts, bless you, shifts the graph to the right.
So really just depending on the sign, it would go the opposite way.
I wouldn't memorize that. I would say, I'm looking for the x-intercept. That will always stay with you. The fact that it's plus or minus may go away, but it's up to you. If that helps you, that's fine. So change in x to x plus 2 shifts the graph to the left 2. Change of x into x minus 3 shifts the graph horizontally to the right 3. So now I'm going to create a combo. So let's say f of x equals the square root of x plus 3 minus 2. Okay, first question here is what function did I use to create this one? Of course, I used a different function this time, so the base function is indeed the square root of x. Great job. Note, very important note, all transformations must be presented in the order of operations. Okay, let's see what I mean by that. Let's look at this function. If I ask you to evaluate this function, let's say for x equals 6, which operation would you perform first? Which one? Exactly, I have 6 plus 3. That's the very first operation, no discussion. If I don't create or determine 6 plus 3, square root cannot be applied. So that's my first operation. After I'm done with that and I apply the square root, what is the second operation I apply or I perform? Subtract 2. So that's the correct order of operations. Therefore, the transformations must be presented in the same order of operations. Same thing, same order. So now, I will ask you to give me the first transformation on the square root of x. Number 1. Which transformation we apply on the square root of x? First one. Which one? We just said that it has to be 6 plus 3, right? So it has to be the square root of x plus 3, and you will have to say it shifts the graph horizontally where? Left, how many?
3.
Excellent. Left 3. Transformation number 2, which is the square root of x plus 3 minus 2, is a transformation on function 1. It's no longer on the base function. We're done with the base function. It's gone. So which transformation will I apply? First of all, I have to identify this doesn't change. This change does not touch x. It's completely outside. So what does that mean? Down 2, indeed. So by simply identifying the transformations, we don't really need to graph. We will in a second. So what is the graph of the square root of x? This is the square root of x. I move it to your left 2 and then down 2. Well, to your left 3 and then down 2. I can picture the graph. It's this, right? It goes to your left 3 and down 2. Done. By simply understanding transformations, and we only looked at 2 of those. So now let's graph. Yes, please.
Can you go over how you got less 30 again?
I'm sorry?
Can you go over how you got less 30? Like the first
So
step.
x plus 2 shifts the graph to the left 2, and x minus 3 shifts the graph to the right 3. So x plus 3 is left 3, based on the same concept from before. Is that better?
Yeah.
Perfect. So we graph the square root of x. We graph x plus 3, you told me left 3. And then you said down 2. So this is square root of x plus 3 down 2. Now here's the question. Is this a perfect graph? Far from being a perfect graph. Do I know exactly that the function crosses the x-axis, the y-axis here and the x-axis here? No, absolutely not. I like to determine the x and y-intercepts, just for the sake of the argument. So find x and y-intercepts. How do I find the x-intercept? Very good. So then I have the square root of x plus 3 minus 2 equals 0. Now I have to think and analyze this and ask myself what type of equation is it? And the answer is?
Easy. X equals 1.
We don't have equations called easy. Well, we have an equation called radical. And yes, the square root of x plus 3 equals 2. And yes, I'm sure you're going to tell me because we had this on the test. So x plus 3 equals 4. Indeed, x equals 1. So I wasn't far from the truth. Not too far. So 1 comma 0. However, when we use transformations to graph, we don't care about the exact graph. We just want to picture the graph and know what's happening there. That's really what we want, for the most part. And then I'll show you an example at the end of the section, a word problem. Okay, how do I determine the y-intercept? Yes, so f of 0 will be the square root of 3 minus 2. And that will be approximately, the square root of 3 is 1.7 minus 2. It will be negative 0.3 roughly. I wasn't too far from the truth. Very good. Moving on. Questions? Questions? Okay, we'll have plenty more examples in a minute. Okay, so let's take a look at the following set of problems. F of x, negative the square root of x, and the next pair of functions I meant to say. The square root of negative x. Now I will ask you, of course, what function did I use this time? And you will say that I use a base function or basic function of, very good. Remember, the next question must be, what am I changing? It cannot be both. It can only be one or the other. So I compare. I compare the square root of x with the square root of x, and then I see a minus outside that does not touch x. So therefore, this must be what type of transformation? On the x-axis or on the y-axis? Am I changing x or am I changing y? Absolutely y. Excellent. Well done. I love it when you pay attention. I really do. It makes it so much easier. Thank you. I really appreciate it. Okay, so here's the graph of the square root of x with positive in front. So when the change happens in y, all positive values of y change into negative values of y. Or all negative values of y with the minus in front will change into? Good. So what type of? Yes, with respect to? That's it. So here's the graph. Here comes the graph of negative the square root of x. So reflection with respect to the x-axis. Excellent. Okay. Now I compare for the second function. I look at the square root of x, but then I look at the square root of negative x. Oh. So the minus touches x. So it cannot be a transformation on y. It must be a transformation on x. So now, from positive x to negative x, or from negative x to positive x, with respect to? Exactly. So here will be the graph of the square root of negative x. So this graph is a reflection with respect to the y-axis. We're going to look at the combo next, and then we'll address the last one.
How do you calculate the I?
How do I calculate what?
The I.
Very good question. Very good question. So here's the question. Okay, Taylor is asking this question. What is the domain of this function? That's his question, basically. And everyone will answer, negative x must be greater than or equal to 0. And multiply both sides by -1 will give less than or equal to 0. So therefore, this function is defined between negative infinity and 0. For any negative number, the negative in front of x will take care of it. There is no I in here. Very good question. Is that clear?
Yeah, it's just a blonde.
Perfect. I expected that from you. meaning to come up with an intelligent question. That's what I meant.
I see what you mean.
Okay. So now we go back here to cross or check the other two, the middle ones. Done and done. So before we look at the last two, I want a combo to practice with. So here it is. F of x equals negative the absolute value of x plus 2 plus 4. Before doing anything, we have to graph this and picture it with our minds. Okay? I have the absolute value of x. Where do I go? Order of operations. No, please. Order of operations. Where do I go? Left 2. What do I do next? No, order of operations, please. So I move one more time. I move to your left 2 units. And then reflect. And then upward. That's the correct sequence. So do we know the graph? Yes, we do. We have to reflect. We have a minus in front. Have a minus in front. So first you have a horizontal shift of 2 to your left. Then you must reflect in order of operations. You cannot perform this before you multiply by -1, right? If you're evaluating for 5, you say 5 plus 2 is 7. The absolute value is 7. You don't say plus 4. You have to multiply by -1 first, right? And then you add 4, right? So the absolute value of x, 2 to your left, reflect because it's a minus in front. That does not touch x. It must be a reflection with respect to the x-axis, and then upward. You know the graph. You don't need to graph, basically, but let's do it. So, base function, please. Absolutely. Number 1, which is the first transformation on the absolute value of x? Very good. What does this do? Left 2, very good. Transformation 2, which is the opposite of x plus 2, is the transformation on function 1. What is it? Very good. Reflect with respect to the x-axis. And function 3 is a transformation on function 2. See, nothing happens here, but it is outside the positive 4. What does this do? Careful. What does this do? Very good. Excellent. So let's graph. Although I know you already pictured the graph, you know how it looks like. So here is the base function. And then you told me left 2. Fine. So that's an absolute value of x plus 2. Then you said reflect this. Okay. This is negative the absolute value of x plus 2. And then you told me up 4. This is the final graph. Let's determine the x and y-intercepts algebraically. How do I find the x-intercept? Very good. Y equals 0. Negative the absolute value of x plus 2 plus 4 equals 0. What do we do next? What type of equation is it, by the way? Of course, it's an absolute value, right? It has absolute value in it. Absolute value, good. So then we have negative the absolute value of x plus 2 equals negative 4. I saw on the test you distributed, you took out from the absolute value. You cannot do that. Please remember, you cannot touch the absolute value. You cannot factor out. You cannot put anything in. You cannot simplify. So what will be our next step?
Divide by -1.
Excellent. Divide or multiply is the same thing for -1. Excellent. Good. So now every time you see an absolute value, you know there are two possibilities, x plus 2 to be and x plus 2 to be. What can it be?
-6, 2.
Yes, he meant -4 and 4.
But
I know. So, and x equals 2 indeed. So, am I correct with my graph? Maybe. 2, 3, 4. Nah, not exactly. But I'm not expecting to have a perfect graph anyway. And what about the y-intercept? How do I get the y-intercept? Finding f of 0. So negative 0 plus 2 plus 4, that would be?
0.
One more time.
2.
Very good. So do I have that? Nah, approximately, not exactly. However, as I mentioned, we do not really care to have a perfect graph. It's just understanding the graph quickly and picturing it. Okay, so let's take a look at the following. Any questions for me? Any questions? Anything? So let's look at 2x squared and g of x, let's say 1/2 x squared. Can anyone give us the base function here? Which function did I use? Correct. So the base function is x squared. And let's graph it. Here is x squared. We've been graphing x squared for quite a while. And again, I have to make a decision whether this is a transformation on x or a transformation on y. So here's my suggestion here. I see x squared. I see x squared. Nothing touches x. But I see a 2 in front. It's 2 outside of the function, outside of x squared. So yes, it's a transformation on y that multiplies all y values by 2. So this piece is doubled. This piece is doubled. So now the graph will be this. So this is twice x squared. It doesn't mean that you have to graph it longer. What I wanted to show is that it's a vertical stretching. The graph gets closer to the y-axis. And we call that a vertical stretching of the graph by a factor of 2. Stretching. Vertical stretching by a factor of 2 in this case. Now, again, I compare x squared to 1/2 times x squared. What do you think this will do to the graph? Still a transformation on the y, but what will it do?
Shrink it.
Yes. So this height gets halved. This one gets halved, and so on and so forth. My graph is not symmetric. Sorry about that. So this is 1/2 x squared, and we call this vertical shrinking of the graph. This one. In other books, they have other names. It doesn't matter as long as you understand the procedure. Okay, let's look at the combo and then the last one. So okay, so this is a vertical stretching and shrinking. And we have the last one to look at. Ready? So let's say f of x equals -2, the absolute value of x minus 2, and plus 4. Which base function did I use now? I meant to write base. Sorry about that. Okay, so let's picture the graph before we even graph it. We don't even need to graph this one if you're okay with that. So I have the absolute value of x. Where do I go? To your right 2. Then I have to stretch it by a factor of 2. One more time from the beginning. So this is the absolute value. I go 2 to your right. I stretch it by a factor of 2. Then I reflect with respect to the x-axis and then upward. Is that clear? Yes. So I have the absolute value of x. I go to your right 2. I have to stretch by a factor of 2. The branches get closer together. I have to reflect because there is a minus in front. And then I go up 4.
Why are you going to the right?
I'm sorry?
Why are you going to the right?
Okay.
Absolutely.
So we go to the right for the same reason we for x minus 3 we went to the right. So x minus 3 goes to the right because the x-intercept will be at 3, not at -3. Is that okay? Yes, everyone? Okay. So I'll let you graph that one, and let's move on to the last one. Everything we discussed so far was kind of common sense. Would you agree?
Sure. No.
Well, I can't please everyone, I know that, but the majority says yes. So here's my next thought. The last transformation will be exactly the opposite that you would expect. So keep that in mind. Okay? So let's take a look. Let's say we have f of x equals x cubed. Now I'm giving you the base function. The base function is x cubed. And I'm going to ask you to create two functions for me, g of x, g of twice x. Well, unfortunately, I have to use f because I'm using the same function. So I can use two names here. So let's stick with that. For this particular one, I can use two names. Okay. So I would like you to tell me how I create this function from the base function. And the other one, let's say 1/2 x. I don't want you to assume that it's always have to be 2. It can be 3. It can be 1/5. It doesn't matter. But a number greater than 1 and a number less than 1. That's all I'm getting at. So let me not use just 2 and 1/2 because that may create situations. Okay. So ready? We know how to evaluate a function. So this time I'm asking you to evaluate this function for 3x. What would you tell me to write? Very good. Awesome. Like this with parentheses, correct? Awesome. What does this mean? So 3 to the third equals, careful, 3 to the third equals Very good. Times x cubed. Very good. So let's not look at this. Please disregard it for a moment. So can you please tell me whether this is a transformation in x or not, or in y? Correct, right? We replaced x by 3 times x. The change touches x. So this is 3 multiplied by x, correct? Okay, now forget about the first part, and let's look at the last part. When you look at this, how will you graph that? So this is x cubed. And what does 27 in front do? Does it do this? Or it stretches the graph by a factor of 27? Correct. So remember how we started. We said that this was a transformation on x. And when I multiply 3 by x, you expect this, right?
Yes.
A horizontal stretching. Careful again. Let's forget about where we started, and let's just look at this. This is x cubed, but this is 27x cubed. So what does this transformation of multiplying x by 3 really do? Yes, it shrinks the graph horizontally. So that's what I said. This is exactly the in a second. This is exactly the opposite of what you expect. So changing x into 3 times x shrinks the graph horizontally. Horizontal shrinking. Yes, please.
So why does it shrink it
Okay.
if it has to do with x?
Very good. Excellent question. That's why I separated. We are talking about this one now. So this one we agree that it stretches the graph vertically. Do we agree with that? We had it a few minutes ago in which we said that 2 times a function stretches the graph vertically. So then 27 times a function stretches the graph vertically, correct?
Yeah, but like why?
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 Okay, because all we didn't know that. You don't know that that's the case. That's what I'm saying. Don't even look at what I did and how I got there.
No, but I'm saying like looking at that, like you're multiplying x.
No, I'm multiplying y. The base function is x cubed. It's the same with this. So this is x squared and this is twice x squared. This is x cubed and this is 27x cubed. It's the exact same procedure.
Put one in for x.
Yes.
Why is it shrinking?
Look again. This is x cubed.
No, like we get.
And this is 27x cubed. Do you see what happens horizontally? So look at what happens vertically, but at the same time horizontally. So this is x cubed, but this is 27x cubed. And horizontally, the graph doesn't do this, it does this. So horizontally, it shrinks.
So I'm not the
It's the exact opposite, correct. So when we change x into 3 times x, this is a horizontal shrinking of the graph. So what do you think will happen here? So this we have 1/5 x to the 3rd power, which is 1 over 125 x cubed. So when we change x into 1/5 x, what do you think will happen? Yes, because that one will stretch. That one will shrink vertically. And vertical, so this is x squared, right? Vertical stretching means horizontal shrinking. Vertical, right? Vertical shrinking of the graph means horizontal stretching. So this is, yes? So shrinking, horizontal stretching, yes? Let's take a look at an example. Any questions, please? Anything? Any questions? Sure, I'm looking for a function right now. Exactly. These transformations, the horizontal stretching and shrinking, are used more for trig functions. I'm using them with my pre-calc class for trig functions. In your case, I can't because trig functions are not part of this course. So that's why you're not going to see trig functions here. But let's apply this to any graph that we have in the book. So here we see, let's say, this graph. And we can choose whatever problem from here. I recommend 1/2 times f of 2x as a problem. Or maybe 49. And that will clear all the possible questions here. So which one would you like to look at? Which one? The f is right here. The function is right here. It's given. The graph is given. So the question was, do we want to do 49 or 50? 49? Very good. So let's do 49. So in 49, I'm going to copy the graph. So this is 40. Yes, any questions? Oh, yes, of course, of course. I'm sorry. So here's the graph. Very easy to copy. So let's do that. 1, 2, 3, 4, 1, 2. And here, 1, 2, 1, 2, 3, 4. So this is the function f. This is -4, -3, -2, -1, 0, 1, 2, 3, 4, and 1, 0. I'm sorry, I don't have to write it twice. 1 and 2. Okay. So we chose 49, and 49 we're asked to graph g of x, which is twice f of 1/2 x. In order of operations, which is the first operation we have to, or the first transformation we have to apply. Exactly. Very good. So the base function is f of x, which is given to us in the form of a graph. The first transformation of f of x will be f of 1/2 x. And the second transformation will be on f of 1/2 x, and which will be? Very good. Awesome. That's it. Exactly. Excellent. Perfect. Okay, then, so now I know that when I change x into 1/2 x, the function does not do this. It's the opposite. What does it do? Yes, by a factor of 2, which means if it's a horizontal transformation, each and every x value gets multiplied by? Excellent. So, of course, we're going to select few convenient points, not all of them. It will take forever, right? I'm going to select this point, and I know this point has the x value, so again, the transformation is not on y, just on x. So this is above -4. Where will it go? What did we say we were going to do? We said we were going to multiply 4 or -4 by, what do we get? No, -4 times 2 is perfect. So at the same horizontal, the graph moves, the point moves here. This point is at -2. Where does it go? Excellent. This point has x equals 0. Where does it go? Stays at 0. Awesome. This point is at x equals 2. Where does it go? Excellent. And this point is at 4. Where does it go? Excellent. Here is the graph. Here is the graph. The green graph is f of 1/2 x. Now this is a different story. Now this is a transformation on y. Now all previous y values get multiplied by 2. Excellent. So this y value for this point is at -2. Where does it go? Excellent. Well done. This y value was at 0. Where does it go?
0.
Exactly. Stays where it is. This point has the y value 2. Where does it go? Excellent. This y value has 2. Oh, I'm sorry, not that one. I'm sorry. This one. And where does this go since it has y 0?
0.
Excellent.
So when it comes to that stuff, we're multiplying the graph.
Of course. This is a transformation on the previous one. This is not a transformation on f anymore. Yes. Good question. So this is the final graph.
Can you remind me what we multiplied with the -8? Is that what that is? It's multiplied by 2, but where does it get the 2 from? Yeah, this one really confused me.
Okay, if you remember, we said that. It's the opposite. If we change x into 1/2 x, we multiply x by 2.
So we're doing the reciprocal.
If you want to call it. That's the only one that is the opposite. Because a vertical stretching is a horizontal shrinking. Exactly. Good. So let's look at a word problem. Any questions? Any questions?
So if the half is a full possible number,
Even instead of 1/2, it's like 3. I would have divided all x values by 3. But the number outside doesn't lie. The number outside, whatever it is, I have to apply it. But for y values. But the number inside is always the opposite of what you expect. Instead of division by 2 is multiplication by 2. Instead of division by 3 is multiplication by 3. Or instead of multiplication by 3 is division by 3. That's the only one. Yes?
Am I gonna do that in the test?
I'm sorry?
I'm not gonna do that in the test.
Why not?
No, I just, I'm not committing, right now I'm not committing it to memory. But do I need it in the test?
Yes, please. So let's take a look. Here is a problem that I would like us to continue with. Okay, so they say that the function 2.9 times the square root of x plus 20.1. Any questions? Any questions? Any questions, please? Thank you. Models the median height f of x in inches of boys who are x months of age. The graph of f is shown. The first question is asking us to describe how the graph was determined.
Is that anything for base?
The base function is very good. That's how we start. Excellent. And then what is the next transformation?
Multiply by 2.
What does that do? Is it vertical or horizontal?
It's
Vertical.
vertical.
Of course, by a factor of 2.9, which means a vertical stretching. Excellent. And then what does this do? Bring it up 20.1. And that's the graph. Very good.
If the 2.9 was in the square with the x, that would have made it vertical, or the opposite?
If you have, you're saying if 2.9 is the square root of 2.9 times x,
Yeah.
you will have to divide by 2.9 for the horizontal shrinking of the graph. Because remember, this is a vertical stretching now. If you put 2.9 in front of x, then it's going to be a horizontal shrinking. Very good. Question number part B. According to the model, what is the median height of boys that are 48 months old? So let's take a look back to the graph. So they are asking us for the median height for 48 months. For 48 months, I'm not sure, but I would read 40, right? Roughly, this is 50, so 48 months is pretty close, and I will read 40 inches. Would you agree, roughly? Yes? Very good. So now let's continue with the rest of the question. I'll write it down right now. It's 127. on page 296. And we already answered how to what the function is doing and how the transformations were applied to the original function, to the base function. So let's look at part B. So it is, again, they say that we got f of 48 from the graph. We read 40 inches. Use a calculator to run to the nearest tenth of an inch. The actual median height, they say, is 40.8. So we read from the graph 40. Now let's put it in the graphing calculator. Okay, so we have 2.9 times the square root of x. I like parentheses, you know that already. And then plus 20.1. And then I'm going to plug in. I want to plug in 0. I want to plug in 48. And see what happens. So the model gave us 40.192. The actual, they say, is 40.8. So this was from the graph. This is the actual. And the function f of 48 gave us 40.192 inches. The question is asking us to describe how well the model, or tell how well the model describes the actual height, median height. Is it a good approximation? So the actual height was 40.8, but actually we determined with the model 40.192. Do you think that this is a good approximation? It's a very good approximation. I don't know if it's a good model for all months, but definitely for 48 it appears to be a good model. But I don't know if for 0 is good, and for 2 is good, or for 15 is good. But definitely for 48, I think it's a good model. Okay, part C. Use the model to find the average rate of change. We just had that on the test. Average rate of change in inches per month between birth and 10 months. So in part C, they went from 0 and 10. And for part D, they went between 50 and 60. So they want us to determine the average rate of change for these two. What do I